This is a quick video just going over everything that you need to know for the indices topic. The first thing are what prime numbers and composite numbers are. So if we look at any number, for example, the number 19 here, 19 has only got factors 1 and 19 because we can't think of any other numbers that multiply to give 19. So 19 is what we call a prime number. So prime numbers have only two factors, the number itself and 1. Composite numbers have more than two factors. For example, the number 10. So 10 is 1 times 10 is 10, but 2 times 5 is 10. So therefore something like the number 10 is called composite because it's got more than the factors of 1 and 10. Then looked at in indices are square numbers and cube numbers. First we'll just look at square numbers. Square numbers come from numbers which can be arranged in a square. For example, this little green square down here has side length 1 times 1. This square here has side length 2 times 2. This square here has side length 3 times 3. So if we look here, our first square number is 1 because 1 times 1 is 1. So 1 squared. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. So they're the square numbers. Just looking in this table, I've just got the first few square numbers. 1 squared is 1 squared, which is 1 times 1, which is 1. 2 squared is written as 2 squared, which is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9, etc. 4 squared is 4 times 4, which is 16. The next thing that we're going to look at is square root. So square and square root are related. Square root is sort of the opposite of squared. So the square root of a number is a special value that when multiplied by itself gives the original number. So we know that 4 times 4 is 16. So we say the square root of 16 is 4. There's a special symbol for square root and it looks like that. It's sort of like a division sign with a bit of a hook at the front. So if I, for example, ask you what the square root of 36 is, you have to think what times what gives me 36? It's the opposite of squared. So what squared gives me 36? We know that 6 times 6 is 36. Or 6 squared is 36, therefore the square root of 36 is 6. Now in this table down here, we're just going to look at the first few square roots. So this is the symbol for square root. Square root of 1 means what times what gives me 1? Well, 1 times 1 is 1, so the square root of 1 is 1. The square root of 4. What times what equals 4? We know that 2 times 2 is 4, so the square root of 4 is 2. In other words, 4 is what squared? Square root is the opposite of squared. Square root of 9. What squared gives me 9? Well, 3 squared is 9, so therefore the square root of 9 is 3. Square root of 16 would be 4 because 4 squared is 16. If I go to the bottom of the table, for example, the square root of 100. Square root of 100? 10. Yeah, 10 squared is 100. So that's square root. Got the idea? The next thing that we're going to look at in this topic are cube numbers. Just like square numbers, you make a square. Cube numbers, you make a cube. So basically, you've all seen cubes. You've seen them in primary school and everything. This is 1 cube with side length 1, 1, 1. So if we work out the volume, it's like you're working out the volume of the cube. It's 1 times 1 times 1 is 1. Here I've got a cube with side length 2. See, I've got 2 cubes stacked up and 2 cubes stacked backwards. If I counted how many cubes I've got, I'd have 8. But what I can do, instead of counting the cubes, I can go 2 times 2 times 2 is 8. So 2 cubed is 8. Here is a cube with 3 high, 3 back and 3 across. So if I want to count how many cubes, I know I've got 9 in each layer and then there's 3 layers, which is 27. Or I just go 3 times 3 times 3 is 27. So I say that 3 cubed is 27. All right? So 4 cubed would be, what would 4 cubed be? 4 times 4 times 4, which is 64. And I'd write it as 4 with a little 3 on top, okay? So, etc. Got the idea? They're cubes. Now, the opposite of cube is cube root. Now, we know that this cube here, for example, has 2 by 2 by 2. It's got 8 cubes in there. So, cube root is the opposite of cubed. So, the cube root of a number is a special value that when cubed gives the original number. So, we know that 2 times 2 times 2 is 8. We can see that here, that's 2 cubed. So, the opposite of cubing is cube root. So, we can say the cube root of 8 is 2. And we write it like this. The cube root of 8 is 2. What times what times what gives me 8? It's 2 times 2 times 2. It's got to be the same number. So cube rooting a number is the opposite of cubing it. So cube root of 1. What times what gives me 1? Well, 1 times 1 times 1 is 1. So girls, there's a little mistake here. There's a little mistake. I should have the cube root symbol here. So the cubed root, one sec, just noticed a mistake on my sheet. So the cubed root of 1 is 1. The cube root of 8 is 2. And, sorry, I've ruined that. One sec. So cube root is what number multiplied by itself 3 times gives me 8. Now 2 times 2 times 2 is 8, or 2 cubed is 8. So the cubed root of 8 is 2. If you're asking for the cubed root of 27, you have to think what number times itself 3 times gives me 27. It's 3 times 3 times 3 is 27. So we say the cubed root of 27 is 3. Okay? That's cubed root. Cubed root of 64 would be 4 because, so the cubed root of 64 is 4 because 4 cubed, it's because 4 cubed, which happens to be 4 times 4 times 4 is 64. Okay? So because 4 cubed is 64, the cubed root of 64 is 4. So that's cubing and cube root. The other thing for the indices topic are the divisibility tests. Just quickly going through that. We know that a number is divisible by 2 if it ends in 0, 2, 4, 6 or 8. Okay, you all know that from primary. A number is divisible by 5 if it ends in a 0 or a 5. So I could look at these numbers here and I know this is divisible by 5 and so is that. The other two are not. We know that a number is divisible by 10 if it ends in a 0. So the numbers that I'm circling here are divisible by 10. A number is divisible by 3 if the sum of its digits is divisible by 3. So with this, I add up the digits. 2 plus 5 plus 9 plus 6 plus 1. That adds up to 16, 23. That is not in the 3 times tables. The next one, 2 plus 9 plus 5 plus 0 plus 5. That's 10 and 11. That's 21. That is divisible by 3. So therefore, 29505 is divisible by 3. So a number is divisible by 3 if the sum of its digits is divisible by 3. So that one's asked in a lot of exams. So the next one, 2 plus 6 plus 3 plus 2 plus 0, 8 and 5 is 13. That's not divisible by 3 because 13 is not in the 3 times tables. And the last one is 16 and 6, 22, sorry, 24, That's 24, sorry. That is divisible by 3. So therefore, this last number is also divisible by 3. And the last rule that you need to know is the divisible by 4 rule. And a number is divisible by 4 if the last 2 digits are divisible by 4. So it does not matter how long or big the number is. I just look at the last 2 digits. Now I know that 24 is divisible by 4 because it's in the 4 times tables. So that's yes. Is 54 in the 12 times tables? Sorry, in the 4 times tables? No, it's not. Because we've got 12 fours are 48, then 52 and 56, that's not. Would 66, is that divisible by 4? Well, you can try it. 4 into 66 goes once to remainder. You've got 6 and you've got remainder 2, that is not. And the last number here, 08, is 8 divisible by 4 or 08? Yes. So they're the basic rules that you need to know. Okay? There is also a number is divisible by 6 if it's divisible by 2 and 3. That's the other one. So a number is divisible by 6 if it is divisible by both 2 and 3. And we showed you how to do 2 and 3 earlier in the video.